Welcome to the next part of this exercise. Here we have then the results for the most recent verification of the members, and through which, as pointed out earlier, we find that the members corresponding to the bracing system exhibit an efficiency ratio way beyond their load capacity. And just to remember, we are currently using a W section of 10 by 12 for this particular group of beams, whose specific characteristics we can find through the section database dialog. In any case, it's evident that this section cannot bear the weight of the concrete deck, posing a risk of fracturing its surface, leading to serious damage to the bridge structure. Therefore, the next logical step would be to search for a more robust section that provides greater load capacity. Now this process is quite straightforward, as it involves testing different sections until we find one that offers the best weight to load capacity ratio. So let's go ahead and choose a different section for the members belonging to the bracing system. Change that once again we can carry out through the Properties panel. Let's for example choose a section of 16 by 40. If you don't find this particular section already on this list, remember that you can define it through the sections dialog. So, and with the new section now assigned to these members, let's continue by requesting the calculation of the model. However, we don't anticipate encountering any errors, as we haven't made any changes to the disposition of the bars. Then let's carry on and request once more the calculation of the steel members, so we can verify if on this occasion we have obtained a better efficiency ratio. Let's just double-check that all members are being considered in the verification, and initiate the calculation. While there has been an improvement in the efficiency ratio of these bars, it remains evident that their current load capacity is still inadequate. Therefore, and as part of the process we described earlier, we should next try with a different section. Let's, for example, use a section of 18 by 76. Again, if you don't find this already listed in the Properties panel, remember that you can define it through the sections dialog. Next, due to this change, let's request once more the calculation of the model. And continue by requesting the calculation and thus verification of the steel members. Well, this time we have finally obtained an adequate efficiency ratio for all members. Furthermore, we have also managed to improve that which corresponds to the main beams in the structure. Namely, we have achieved a more stable design overall, and that, let's note, it's considering multiple load cases. Then, to continue, let's have a look at the resultant weight of the steel structure. As we can observe, due to the change in the size of the sections, the weight of the structure has increased to 65 tons, and although this is a much heavier structure than before, it now offers better stability and a sturdier framework. However, we haven't yet concluded the design of our bridge, as a crucial aspect that now requires attention is the careful placement of the connections. Since let's remember that the presence of this upward camber also produces significant internal forces at the meeting point of these elements. Thus, in speaking of the connections, these are very likely to require a bolted setup instead of a welded one. Then let's carry on and begin working on the connections for this structure. See you in the next video.